So we're now going to look at an application of limits to what we call asymptotes. And asymptotes are basically limits of the form lim x goes to plus or minus infinity of f of x. And if this is equal to L, what does this mean? Well, this means, so if we just think of the plus, this means that we have L here, and that the function somehow gets closer to this line as we move towards infinity here. If I put a minus here, then the corresponding would be true when I go to minus infinity. And we say that the function has this line y equals to L as a horizontal asymptote when we go towards plus infinity or minus infinity or both. It could be that you have different. So here you go towards L and here towards, I don't know, minus L. Or it could be that you have no horizontal asymptote, like this sign, for instance. It just wiggles around, not approaching anything. You can have vertical asymptotes. That's what happens if, when you go towards some finite number a, you have f of x equal to plus or minus infinity. And to have a vertical asymptote close to a point a, then it's enough that you explode like this from at least one side. So it's enough that one-sided limit like this, for instance, gives you this. Then you have a vertical asymptote here. From the other side, you might perhaps do this. Or you also go to plus infinity, or you go to minus infinity. So there are other ways to have vertical asymptotes. Basically like this, and this, or this, and this. And finally, there are what we call skew asymptotes. Skew asymptotes are what you get when your function gets closer to some skew line. So let's call this y is equal to kx plus m. So if your function approaches this line when x tends towards infinity, you have this skew line as an asymptote, a skew asymptote or an oblique asymptote. And this we recognize by saying that the lim as x goes to plus or minus infinity of f of x minus the vertical distance here. And we don't have to do this in absolute value, so we just do it like this, is equal to 0. And then you can notice that this thing here, I can write this as lim x tends to, say, infinity of f of x minus L. So if this line here has k equal to 0 and m equal to L, this skew asymptote is in fact a horizontal asymptote at y equals L. So a skew asymptote is basically a horizontal asymptote with a non-zero slope. So let's now look at an example of finding asymptotes. And the function we look at is f of x equal to 1 divided by square root of x squared minus 2x minus x like this. Asymptotes. Now, to find vertical asymptotes, we need to figure out, are there any finite points, so finite points a, such that when x tends toward a, this tends to infinity. Now, if the thing down here is defined and non-zero, then clearly we're not anywhere close to infinity. So we need to figure out when is this 0, okay? So first vertical asymptotes. So then the first thing we do is we investigate when is this thing here equal to 0, okay? That's our only hope of finding a vertical asymptote here. So this means if we shift things around a little bit, we get this. And now we can square both sides. So this gives us x squared minus 2x equals x squared. Now taking square roots, I should have put plus minus here. So we only have this arrow. We don't have the arrow back up, meaning that we may get false solutions here. So we have to be careful. But solving this, we see that we get, well, 0 equals to 2x. So this happens only if x is equal to 0. And now we can put 0 in here, then this becomes 0, and this becomes 0. So as x equals to 0, we actually have a 0 of this thing, and there we may have a vertical asymptote. Is it clear that we have a vertical asymptote there? Well, not really, okay? So we need to check the limit as well. This is our candidate. So this is only candidate for vertical asymptote. Now, before we take the limits, and probably we should do it one-sided here, let's check the domain. So is this an inner point or an end point of the domain? So the only thing which is scary for our domain here is, well, either if this is 0, but this happens only there, or if this guy is not defined. So let's see when the root is defined. So let's check when this is bigger than or equal to 0. And this happens if x minus 2 is bigger than or equal to 0. Now we can make a table of signs for this. So we have your x, you have your x minus 2. He flips signs at 0 and he flips signs at 2. So he's negative here, 0 here, and then positive. And this guy is negative all the way here and then positive. So all in all, this guy is positive here, 0 here, negative here, 0 here, and positive here. So this means that, well, this is if and only if x is less than or equal to 0 or x is bigger than or equal to 2. So this means, and this is probably something we should have checked right away, that the domain of f is equal to, well, I'm doing a mistake here. So the square root has this domain, but then this is 0 when we're at 0, so we need to open it here like this. That's our domain. Now, this means that we can only check if we have a vertical asymptote here by taking the limit from the negative side. So let's do that. So we check with the limit as x goes from 0 minus of 1 over x squared minus 2x minus x like this. We check what it is. And what happens? Well, this tends towards 0 and this tends towards 0. So here I have a limit of the form like this. So this is a limit on this form. So I'm getting a 1 up here, and then I'm getting something that gets closer and closer to 0 down here, which means this thing here is infinity. Well, it's either plus infinity or minus infinity. I'm not quite sure at this point, but I'm definitely getting a vertical asymptote here. If that's all I want to know, then I don't really have to investigate further what the sign is. But let's try to do this. So now I'm going to 0 from the negative side here. So this becomes a 0. So having a minus 0, that's from the negative side here. So all in all, this is giving me a positive. So something that's close to 0, but positive. What about this guy? Well, this is the square root, right? So he's giving me something positive, like this. So this is small and positive minus something small and negative, meaning I'm getting something small and positive here. So that's the guy. I'm going to plus infinity when x goes from 0 from the negative side. So that's a vertical asymptote. Now, do we have any horizontal asymptotes? And then we need to check lim x goes to plus infinity of this expression and x goes to minus infinity of this expression. So let's see what happens when x goes to plus infinity. So first of all, I'm doing this thing here to see if it's a blatantly obvious thing, like it was here 1 over 0. So I don't really have to check that any further. Right, so what happens here? So this goes to infinity. So I have 1 up here. This goes to plus infinity. And here I'm getting minus infinity. And here we just don't know, because these infinities can cancel and give us a 2 or a 3, or they can cancel even more and give us a 0, so that this becomes a 1 over 0 expression. Or it can be that this infinity here is much stronger than him, so this is still a 1 over infinity giving me a 0. So we don't know. What do we do when we don't know? Well, we need to manipulate algebraically. So let's do that. And here, when I have square roots involved, and especially one term minus the other, I can multiply by the conjugate to get at least this thing here to a plus, because infinity plus infinity, well, that's infinity. So it's the minus here that's really messing us up. So I multiply with the conjugate. So I'm here having this thing. And now here comes the conjugate. So it's plus x and plus x. And now what I have downstairs becomes this to the squared, which is just this, minus this to the squared, like this. And on top, I just get what I have, which is now an infinity plus an infinity. So that's not so scary to me. And here I can cancel this against this. So buying myself some space here. I'm having here x squared minus 2x plus x. And then I divide this by minus 2x. And now, what do I have? So let's do an indeterminate form just to strategize. Here I'm getting minus infinity. And up here I'm getting infinity plus infinity. So two positive infinities. So this is all in all infinity divided by minus infinity. I have no idea what this becomes. This could be a stronger infinity, so all of this goes to infinity. This could be the strongest infinity, so this goes to 0. Or this could be equally strong, so this goes to -1, or this could be slightly stronger, so this goes to maybe -2. I don't know. So again, we need to do some algebra here. Now we're having a quotient, okay? And we already know from our discussions on sequences that quotients are good, right? Any caveman knows this. So what we do is now identify strongest terms and factor them out. And x goes to infinity. So, well, we just have the x downstairs. Let's factor him out. And here, let's factor this x together with this x squared. So this gives us, what's left here is just 1 minus 2 divided by x. And then the plus 1. This kills this. And now this goes to 0 and everything else stays put. So I'm getting this, and I'm writing it in this way so that I'm clearly signifying to the reader what rules I'm using here. But I'm being sort of subtle about it, which is nice sometimes. And this is 1 plus 1 divided by -2, which is equal to -1. So as x tends towards infinity, this expression has -1 as a horizontal asymptote. So now comes the question, what happens when you tend towards -1? Well, I'll leave that as an exercise. But I can give you this warning, it's not -1, okay? So it changes.